followed by 20 shots with Mohaupt's rifled prototypes at the same range. 3 different operators for each weapon type to eliminate shooter skill bias. Targets would be measured after each FIVOT group. Hit rate, penetration depth, and jet formation quality would all be documented. First up, the smooth bore baseline. The operator, a sergeant from the Aberdeen Test Detachment, shouldered the standard M1, aimed at the first panzer plate and fired. The rocket left the tube with the familiar whoosh, trailing white smoke. It hit the plate 2 ft left of center with a sharp crack. Engineers downrange examined the impact. Penetration depth of 3.8 in into the backing clay. Decent but not enough to reach a panzer's crew compartment. Shot 2, 4.1 in. Shot 3 missed the plate entirely, sailing wide right. Exactly the accuracy problem that made this test necessary. Shot 4, 3.5 in. Shot 5, 4.4 in. The pattern emerging was inconsistency. Even when the rockets hit, penetration varied by nearly an inch based on impact angle and jet formation quality. By shot 15 of the smooth bore group, the results were clear. 11 hits out of 15 attempts, penetration ranging from 3.2 to 4.6 in, average around 3.9 in. The 4 misses at 50 yards, point-blank tank-killing range spoke volumes. One rocket had tumbled so badly it hit the plate sideways and failed to detonate properly. These numbers matched field test data. They also confirmed what everyone already knew. The smooth-bore bazooka was marginally effective at best. The rifled prototypes came next. Mohaupt had fabricated 3 tubes with spiral grooves cut at a 1/6 twist rate, 1 complete rotation every 16 in of tube length. The grooves were shallow, only 30,000 of an inch deep, just enough to grip the rocket body and impart spin without creating excessive friction. First rifled shot, dead center hit, penetration 7.2 in. The engineers downrange called out the measurement and the observation bunker went quiet. Second shot, 7.4 in. Third shot, 6.9 in. Fu asked for the test to pause while engineers verified the measurement methodology. They remeasured every rifled impact. The numbers held. Testing resumed. Shot 15 with the rifled bazooka hit the thickest test plate. 8 in of rolled homogeneous armor, the equivalent of Tiger 1 glasses protection. The rocket struck dead center, detonated, and sent a spray of molten metal through the observation slit in the test bunker 300 wide away. The downrange crew waited 30 seconds for the plate to cool enough to approach, then called back the measurement. Complete penetration. The shaped charge jet had burned through all 8 in and into the clay backing behind it. Penetration depth in clay 2.3 and beyond the plate face. General Barnes stood up from his observation position. According to the official test report filed later that day, he said 5 words. Run the next 5 shots. The stenographer noted that Crozier objected, stating that sufficient data had been collected. Barnes overruled him. The test continued. Shots 16 through 20 produced results that made Aberdeen's ballistic specialists check their instruments twice. 7.88 in, 8.1 in, 7.6 in, 7.9 in, 8 in. Not a single shot penetrated less than 7.6 in. Not a single shot missed the target plate. The consistency was what shocked everyone watching. Smooth bore penetration varied by 1.4 in across 15 successful hits, a 36% variation. Rifled penetration varied by 0.5 in across 20 shots, a 6% variation. You could predict what a rifled bazooka would do. You could trust it. The observers moved downrange after the final shot to examine the armor plates up close. Every rifled impact showed the same distinctive pattern. A circular entrance hole roughly 2 in diameter, perfectly perpendicular to the plate's surface, with clean edges indicating the shape charge jet had formed correctly and penetrated without deflection. The smooth bore impacts looked different. Irregular holes, some showing evidence of jet deflection or partial penetration, several showing sideways strikes where the rocket hit at an angle. Back in the observation bunker, the ballistics team compiled final numbers while everyone waited. The data was devastating to the smooth bore design. Hit probability at 50 yards, smooth bore 73%, rifled 100%. Average penetration, smooth bore 3.9 in, rifled 7.7 in. Maximum confirmed penetration, smooth bore 4.6 in, rifled 8.1 in. Consistency rating, a statistical measure of result deviation. Smooth bore failed to meet acceptable standards. Rifled exceeded all requirements. But here's the number that mattered most to infantry officers. Probability of defeating 80 frontal armor on a Panzer IV. Smooth-bore bazooka, approximately 15% accounting for both hit probability and penetration failure. Rifled bazooka, 97%. A soldier with a rifled bazooka could reliably kill the most common German tank he'd face. A soldier with a smooth-bore bazooka would die trying. General Barnes convened an immediate decision meeting in Aberdeen's headquarters building. Present Crozier Skinner, Mohaupt 3 ordnance production officers and 2 logistics majors. The meeting lasted 45 minutes. The question wasn't whether to adopt rifling. The test data made that decision automatic. The question was how fast they could retrofit existing production and whether to recall bazookas already in the field. Production officers reported that rifling existing tubes would require specialized equipment, but was mechanically straightforward. Each tube would need to pass through a rifling machine. Essentially, an industrial drill with cutting heads that carved spiral grooves in a single operation. Time per tube approximately 8 minutes. Cost per tube $12 for machine time and inspection. With 3 factories running rifling operations in parallel, they could convert existing inventory in 6 weeks. The logistics officers dropped the complicated news. 14,000 M1 bazookas had been manufactured. 8,000 were still in stateside inventory and could be rifled before shipment. 6,000 had already deployed. 3,000 to North Africa, 2,000 to the Pacific Theater, 1,000 to training bases in England. Recalling deployed weapons for modification would create a gap where frontline units would have no anti-tank capability for 2 to 3 months, while weapons shipped back got modified and shipped forward again. Barnes made the call within minutes. Rifle everything in stateside inventory immediately. Begin manufacturing new tubes with rifling already cut and develop a field modification kit for deployed weapons. The first rifled bazookas reached combat units in April 1943, just in time for Tunisia. The 1st Armored Division received 200 modified M1A1 launchers, the new designation for rifle tubes during the final push against German forces near Bizerte. Staff Sergeant Julius River's after-action report from April 23 described an engagement that would have been impossible 3 months earlier. His team engaged a Panzer IV at 70 yards, fired once, and watched the tank brew up as the crew bilayed out. First shot, total kill. He wrote that his men couldn't believe the damn thing actually worked like they promised. By June, production had shifted entirely to rifled models. The M9 rocket launcher, an improved version with better sights and a 2-piece tube for easier transport, started rolling off assembly lines with rifling standard. These were the weapons that landed at Salerno in September 1943, where the 36th Infantry Division used them to break up German panzer counterattacks on the beachhead. Lieutenant Colonel William Darby's Ranger battalions reported bazooka teams accounting for 11 confirmed tank kills during the first 3 days of fighting. Anzio, in January 1944, provided the real stress test. German forces threw everything at the Allied beachhead, including Tiger the Firmer's heavy tanks that earlier bazookas couldn't scratch. But the M9's aid and penetration capability meant even Tigers were vulnerable if you hit the side armor or rear deck. Private First Class James Arnes, yes, the future Gunsmoke actor, served as a bazooka gunner at Anzio and later described stalking a Tiger through rubble. You knew if you got the shot off clean, you'd kill it. That confidence kept you alive because you weren't panicking, just working. D-Day, June 6, 1944. Every American infantry company that hit Utah and Omaha beaches carried at least 4 bazooka teams. The weapons proved essential not just against armor, but against fortified German positions where the shaped charge jet could blow through concrete gun emplacements. After-action reports from the 29th Infantry Division noted that Bazooka teams cleared 12 pillboxes on Omaha Beach during the first 6 hours, allowing infantry to push inland. The real proving ground came during Operation Cobra in late July 1944, the breakout from Normandy. American infantry divisions advancing through hedgerow country ran into German armor ambushes constantly. This was exactly the scenario bazookas were designed for close-range surprise engagements, where portability and first-shot effectiveness mattered more than tank gun range. The 4th Infantry Division logged 37 confirmed armor kills with bazookas during Cobra's first week. Tank destroyers and Shermans got most of the credit in official reports, but infantry journals tell a different story. Bazooka teams often killed German tanks before friendly armor even arrived. The Ardennes Offensive in December 1944, the Battle of the Bulge, tested everything. German Panther and Tiger tanks smashed through American lines in fog and snow. Isolated infantry units found themselves defending crossroads and towns with bazookas as their primary anti-tank weapon. At Bastogne, the 101st Airborne used M9 launchers to knock out at least 18 German tanks during the siege. Captain James O'Neill, a company commander with the 5,002nd Parachute Infantry, reported his men ambushing a Panther column on December 22nd, killing 3 tanks in under 2 minutes by hitting them from building positions at 30 yards. The consistency made all the difference. Soldiers learned they could aim a rifled bazooka like a rifle. Point, squeeze, hit what you pointed at. Technical Sergeant Forrest Guth, who fought from Normandy to the Rhine, explained it simply in a 1945 interview. Before rifling, you fired and hoped. After rifling, you fired and knew. By the time American forces crossed the Rhine in March 1945, bazookas had accounted for over 800 confirmed German armor kills in the European theater. That 800 number tells only part of the story. The real revolution happened in how armies thought about infantry anti-armor weapons. Before rifled bazookas, portable rocket launchers were experimental gear that might work under ideal conditions. After Aberdeen's January 1943 test, they became primary weapons that infantry commanders built tactics around. And every rocket weapon America developed afterward started with one assumption: the tube will be rifled. The 3.5 and M20 Super Bazooka that appeared in 1945 came with rifling machined directly into the tube during manufacture. This weapon could penetrate 11 in of armor, enough to threaten even King Tiger tanks from the side. When North Korean T-34 tanks crossed the 38th parallel in June 1950, American infantry units stopped them with M20s, weapons that existed because Mohaupt convinced skeptical officers that spinning rockets was worth the risk 7 years earlier. Korea proved rifling's value in ways World War II never did. The terrain, mountains, narrow valleys, urban fighting meant tanks and infantry fought at ranges under 100 yards constantly. The M20's accuracy let a 2-man team engage armor from protected positions with confidence. After-action reports from the Busan perimeter fighting in August 1950 show bazooka teams accounting for 41 T-34 kills in 2 weeks. First Lieutenant Ernest Schoenfeld's platoon knocked out 7 tanks in a single day near Taegu using tactics that depth.